So everyone gets his own way converting JSON, right? Whatever the language is. Mostly we find solutions online, plugins and libraries. And one thing that makes them common use is that we convert one file, we copy paste, and we get data class back. And that's when we use plugins, and when we use libraries, we can do that automatically. But what if we want to do that for 2 or more JSON files at the same time automatically, and this time we want to convert directly from a file, also be able to convert many files no matter locally or online. So let's explore some of the methods that's already out there. The first one is JSON to Kotlin class plugin. We can batch process JSON files, configure it to read multiple files, and generate corresponding data class automatically. This one requires a little bit of tweaking, but it might work. The second one, we can use online batch converters. As you know, some tools online allows you to upload multiple JSON files and convert them to data classes in one go, but it requires us to abandon our development environment, so there's the downsides to it. The third one is JSON schema to Pojo. Primarily this plugin is for Java, but you can use the tool to generate Java classes from JSON and then convert the classes to Kotlin. This one still requires some manual handling. The fourth one is JSON to Kotlin fractal range. This tool is implemented in Kotlin and it utilizes the Kotlin Poet library. So it is a bit efficient than the previous methods. Or the last option, the fifth, is custom script. You could write a custom script in Kotlin or Python that reads the JSON file, process it, and generate data classes. And this can be done using libraries like JSON or Moshi. But still, in our case, we do want to use this method, custom script, but what if we don't want to use no library? For example, let's say we're handling frequently changing JSON field names, and it's not possible for us to work with the API providers. Let's say it's a public API and the names change frequently, and this will not give us the opportunity to utilize libraries with annotations. For example, JSON in Java, we use the JSON property, and we can't use that because we don't know what the field name is gonna be tomorrow. So creating your own JSON converter will not only give you the opportunity to set up a batch that will notify you on what changed, but also you will be able to get further and create a wrapper class that sort of refactor and rename the changes. It also gives you the chance to update field types as you like. example, double to big decimal in Kotlin. So let's get started. So first thing we need is a converter interface, and that will be used for other languages as well. So we need two functions, one that reads the JSON file and pass it to the converter that expects it as a string. And we create all the possible languages we'll be covering. Convert file will only read the JSON and pass it to convert function. Let's consume this class from the main. So first thing first, we want to get rid of any space, any new line. This will make it easy for us to work on. Here we can also get all the field types that is not in a list, because field types comes after colon, so we can target string field types, doubles, integers, etc. So any text that's inside a quotation mark and after a colon, that's a string. Then we do the same thing for integer. integer will replace the one we expect as double as well. So let's change the release year to double for now. As you can see, it changed it to int comma, but that's not a bad thing. We can use this one to target double next. After we set all the single field types, we do some cleaning. Two colons to one, and anything that starts with right square bracket with a quotation turn to right square bracket comma quotation. Now we split all the commas and we join the string. As you can see, other than the list types, everything is cool. Now this is where it gets interesting. So far we did what we can with the string itself. Now we go through each char and do mapping. So when we go through each char, when we find left curly bracket, that's an object opened, is it? And when we find right curly, it goes object. So first thing first, we do that. For now, everything else we update the object. We don't create any new object, we just pass update. So what we want from these three functions is something like this. So we need the new data class, work in progress object data class, and that will hold the value that we pass in, if the object is still open or not, and we pass an ID because we'll likely see multiple. So I will be working on one mutable list, and I will hold everything. And of course, we need the first object name will be the initial name. One extra function that will give us the last open object. And also, when we are updating the object, we can pass a boolean to close the object. So also close it boolean defaulted to false. Now let's try it and see what we got. As you can see, we got 5 data classes, and that's because the list is 5. So it's coming. So things will get a little more interesting. So the char values that we pay attention to is curly brackets, square brackets, colon, comma, and quotation mark. Everything else keep adding to the object that is currently open. And when it's left square bracket, we don't want to add anything, do we? Because we know we're inside the list and we only want the first type, so we need look val maker. If it's false, only we add. So here we need to access the next char. So let's change on each to on each index it. That way we can get it. So when it's a list and when the next char is a left curly bracket, we know it's a list of an object. So when we see object, we unlock the val maker. Also, if it's the right curly bracket that followed, then we know it's invalid. JSON, so you can throw an exception, whatever exception you want, runtime or custom one, but we know it's invalid JSON. You don't want to do nothing if the same square left square bracket followed, and if it's right, then without any field type to discover, the list got closed, so we say any, something like this one. So we don't want to do nothing to colon, comma, it's invalid, so it's one exception. Here, if the followed is quotation mark, then we know it's a string, so we add list of string there. And everything else, let's just again turn release here to a list of double for now. In order to determine what field type the list is, we only get the first 5-6 characters in the list. That is enough, I believe. Let's just say for now, if it contains numbers, let's just turn it to a list of big decimal for now. And everything else to any. The next thing we'll pay attention to is the colon. We're still gonna add it that here, if the next char is left curly bracket, then we're gonna create a new object. We're about to be, so we need to update the object name. Also, if the next char is left square brackets and the next thing that follows the square bracket, if that is curly, we still need to update the object name. And how do we get the object name? We get everything that is before the last quotation mark, and we split the last one. That's how we get it. Okay, here films should be separated, so we need to check what we missed. Films list. Yeah, we need to close the first one. That's one issue. Okay, now it's separated, and yeah, oh yeah, the split should be in quotation. That's it. We got it now. Films capitalized. So let's print it with a little bit of tidying. Since we got the ID there, we distinct by it. And then for all the values, the first quotation mark replaces the one before colon, and the next quotation mark we replace is with val. Okay, let's see our result now. Nice. It's coming now. Okay, duplicated, which is not what we want. So let's see. It's part of the list, so here we also replace all the comma with nothing. As you can see, we got it correctly now. Now instead of print, let's just pass it to the main class. Okay, as you can see, the main class is also fine. Can print it successfully. Now it's time to generate it, and it is recommended that the initial name that you passed should also be treated as a file name, which is common most times. So now let's update the generate function. there is an exception, we want to print it. That's it. Now let's run it. Should be able to see. Oh, okay. We just missed the .kt, the file extension. Once we pass that, it's all good. Here we go. As you can see, got the class successfully now. Even though we were able to generate simple JSON to a data class, we still gotta cover list in a list field, object in an object, and more complex JSON files, and that'll be available in part 2. Thanks for watching.